Good evening, YouTubers. Welcome to episode 23 of ShrigleytubeTV. I've been a bit busy this week with a 930cc engine just since Wednesday, obviously, when we did the prize draw with the t-shirts. Thanks to everyone that's emailed me. I have received all of your addresses and everything is all wrapped up, ready to go in the post on Monday night, so hopefully you'll receive your t-shirt in time for Christmas. A little message for Simon, who won a t-shirt. He requested a medium. Unfortunately, I've run out. I've only got large, so rather than wait till New Year and order more, I've sent you a large. So have a good Christmas and eat everything in sight, because that's what I'm going to do. Anyway, going on to this week's video, it's just about one engine, a 930cc engine, which I did a bit of head work, a bit of this, a bit of that, and a bit of a chat, and then a bit of a waffle as well. Well, anyway, you can always fast forward if you get bored. Hope you enjoyed the episode, and just what I was also going to say was I've been a bit slow to respond to messages and stuff recently. It's been really hectic, and sometimes I've got like WhatsApp, Messenger, the email, I see messages, they come, they go, I don't find them again. So if you want to get hold of me, please just call me, working hours, you know, Monday to Friday, 8 till 6. If I don't answer the phone, just leave a voicemail and I will get back to you, I promise, and we'll arrange to do something, whatever it is you need to sort out. But yeah, I just got so many different contact methods, I struggle to keep up with them all. So hope you enjoy this week's episode. There is a small mistake in it where I get some figures wrong. I say 55 foot-pound instead of 65 foot-pound, and then I get myself in a jumble, but you'll spot that and probably just laugh and think, what is he on about? So the engine did actually produce about 75 horsepower in the end, a good solid 75, not 63 or whatever. So there we go. Hope you enjoy the episode. I will look forward to seeing you next Sunday, which will hopefully have a bit more. It's only half an hour in tonight. We'll have a bit more in next week's episode, a bit more variety. All right, thank you. Bye-bye. Okay, good morning, YouTubers. It's Monday morning and we're doing some cylinder head work. This head is a 533 casting. Now, I thought we'd have a little chat about the different heads available for Hillman imps. Now, the most common one is what we call a 171 head, which is a Mark II head. And the way you can identify all these heads is if we look at the end of the facing where the timing chain cover is there, they got like a 7198, and then the last three digits on this particular one are 533. If this was a sports head, the last three digits would be 180 or 107 or 162. And if it was a Mark II head, which is what the majority of the heads are, which is a standard imp head, it'd have 171 on it. So this one is what we just said was what we call a 533 head. So this head is one of only two heads that the imps were made with that have an oil drain. So the oil can drain from this little orifice here. Normally the 171 heads, etc., don't have that casting there. They have the oil drain because they ran double valve springs from the factory, and back in the day when all this happened, you couldn't really get a valve guard oil seal that would fit inside the inner spring. So obviously, instead of having a valve guard oil seal, they ran double springs and they had an oil drain for the oil to escape, so it didn't pool basically and get drawn down the guides when the manifold vacuum was up, on idle and that sort of thing. Anyway, so the point of what I'm coming to is, because the sport head casting is now quite a valuable head casting and quite hard to come across in good condition. There's plenty out there, but lots of them have had bad modifications, or they're cracked, or they've got threads missing out of them, etc. So it's put the value of the good ones up high, and that means that people have started looking other ways of getting the same performance on like a fast road engine out of some of the lesser heads. So the next best head obviously is the 533 head. This oil drain 533 head was available for the last 2 years of manufacture. Some people call them like an L4 head from 1974, 5 and 6, because that was the years they made the last imps. The Caledonians had these heads on them with the sport cam, but they didn't have the sport size valves. Now, the main difference between this and a sport head is, unfortunately, you can't go to the full race size on the inlet port because they break through, and on the exhaust there's less material. The cores are different basically, so you can't turn them into a full thoroughbred racer, but you can improve them, because as I've done here, you'll see these three seats I've done, and we'll do the last one together, the inlet seats, and we'll do the exhaust as well. I'm putting it on sport valves because
even though it's on a Mark II size valve, the actual valve seat that's let into the head is big enough to run with the import valves. So because the material's there, we might as well make you know, we're refurbing the head anyway. It's had a skim, it's had a new set of guides. So I thought while we're here, we might as well take advantage of the fact and just go a little bit bigger. It's going on a 930 bottom end, so a little bit more air will help. Now you can see that obviously the seat is massive compared to the size of the throat. It's tiny. I will open all this up in a minute, not massively, but just this area. I'll use the hurdy-gurdy to open all that up, because it's just see if we can get a zoom in. You can see it's quite small inside the throat, so we want to make advantage of all that more area we've given it with the valve seat, with the valve head diameter. So I've set the machine up, it's all on the stop. This is the pilot, put that in. Next part we put in is the tool, which looks like this. We have done a video on this recently, so the hardcore YouTubers amongst you will remember. That goes in there. The head is left floating so that it can self-center, so the head's all loose. We're just letting the pilot that goes in the guide control the tool, because we want the seat to be cut concentric to the guide so that the valve seats properly when we lap it in. So I've got this just on a stop, so when it tries to grab, it stops the head from spinning by hitting that. So we'll turn the machine on and I'll start bringing it down. Now this is the stop here, see that mechanical stop? When that hits there, it'll be the same height as the rest of them, so we know that they're all going to be uniform. So I'll zoom in and we'll just gently touch on. Let it machine the old seat away, and eventually we'll see the new seat start to form at the very biggest diameter. Quite a lot of material to remove really, that's why I'm going at it real gentle, nice and slow. Last thing we want to do is make it snag and wreck itself. The tool's quite sharp, so makes mincemeat of that iron insert. Just see it's just starting to form a seat now. And I can feel a bit of resistance from the stop. So I'm going to lean on it quite hard. And I'm going to leave the pressure on and let the tool rub out. So it gets rid of any high spots and leaves us with a uniform finish, so that the minimum work done to do with the lapping of the valve to get a good seat. Yeah, that's not going any further, that's hard against the stop. Turn that off, pull that out, just do that, pop the tool down. Not getting a very good focus here, I'm not sure why. But anyway, he's done a nice job with the seat. I'll get a bit of torch on it. Camera seems to be a bit fluffy. There you go. So you can see it's cut the seat. I've just got the exhaust to do now, and then we'll open all the throats up, and then that'll be that head to what we call a sport spec 533 head casting. Just to update on the cylinder head, I've done the exhaust ports, the exhaust seats as well now, and I've just opened these up. Not massive, because I'm not sure how big we can go on the 533 casting, but done that, and I've done the short turn on the inside there, so that's nice. Obviously this head now, we're going to clean it and then I'm going to blast it so it's all nice and clean. It's obviously, now you may be familiar with the imp, it has a weak area over cylinders 2 and 3 where they crack. It's really thin here. When you pull the head down, it sometimes cracks. So I've just blobbed it there with some aluminium to give it a bit more strength, a bit more body, and then I've just machined it back. It'll look better when it's been blasted. And then the last bit of work I've done, I've just mildly opened up the not that you can see because everything's covered in swarf and filthy, but what I do basically is I use a pair of dowels, and then I put the gasket onto the manifold, and then I modify the gasket to suit the manifold, and then because this is on dowels again, I transfer it back onto here and then go around it with the hurdy-gurdy so that I know that the manifold, when it's bolted up, when we come to build it, it'll all be nicely aligned. So I'll get all this clean now. Quite a nice pair of carbs for this chap's engine, Nearest, sort of period tuning. These look like what I'd imagine a midget or 1275 mini GT 1.25" SUs. These should work quite well, so I'm quite excited to get it on the dyno, and we'll see what horsepower it's got.
Okay, good morning YouTubers. Just on with this cylinder head for the little 930 engine, and I thought we'd do this little bit of lapping valves together. Very simple operation, but often overlooked. So I thought, we've not really done it apart from when Russell had a go when he was on half term. Normally we sort of skip this part. So this head, I put the guides in it, I faced it, blasted it, I've opened up the inlet ports a little bit just in the throat, nothing massive because it's just a little 930cc engine, we don't want to kill its airspeed. And got the new valves. I've already lapped these, but I thought we'll just go through one together so we can just cover all points. So if you're lapping your valves at home, what we're looking for is a nice contact area on the edge of the valve seat there where we've got the angle matching the angle on the seat where it lands, so we know that contact point we've got a solid grey ring all the way around. So all we do, get some grinding paste, so this is the fine stuff, put it on the edge of the valve like that, and then pop it in the hole. Now you feel it, because it's all dry and clean, it's a bit sort of sticky, you know. So what I like to do is just a bit of your AC90 or WD-40, whatever you've got, just blast it, lubricates the guide a bit, and then what we're looking for is an up down with the contacts each way. So it goes down, contacts up, and that helps keep the grinding paste on the seat. If you just go like that, you'll hear the sound change as it just pushes the grinding paste out of the way. So by doing the up down like that, we keep bringing the paste back to the seat so it can do its job, which is to cut. Because obviously before, when we did the cutting the seats, I went on a bit about how important it was that the valve seat is cut true to the guide. Now there's loads of compromises because the pilot that we put in the guide, which is what the tool centered off, although it's snug, it's not rigid. So there's a certain amount of deflection, you know, as the tool pushes off, etc. That's why we have to go back with the lapping stick and the paste to get a witness mark so we can see that the valve is touching the seat all the way around, and we know then we've got an half decent chance of a good valve seal. So I'll just, won't do this lots. What I'll do is I'll take the camera off the stand when I've cleaned it, and we'll have a little look at it together so we can understand exactly why it does what it does. You can hear the paste has gone off now. Right, I'll turn the camera off, I'll clean this up, and then we'll have a look at it together. Okay, I've given it a little wipe now, so you can see I've opened up the throat, which is this part, to make it a little bit bigger to suit the bigger valve we put in that seat. And also I've done this, which is a short turn. I've just machined that gently just so that the air can turn around it nicely. Now if we look at the valve, you'll see this grey area here. This is where the valve lands on this part of the seat. You see it there? So we've got a nice narrow seat,
I've checked it, and we've got contacts all the way around, so that valve will be dead happy sat in there. If we pop it in, it should make a nice noise, and if we pop that one next to it, so I'll just pull you out of focus a little bit, next to its other one, everything should be the same height now. So as a reconditioned cylinder, we can see both valves sit in the chamber at the same height, which will mean that we've got a good chance of shimming it up quite easily. So this, just to give you a bit more information on this engine, this is a 930. There is some pitting marks on it, but I've placed the head gasket over it, and where the head gasket seals on the fire ring, it's all good. So these areas are just outside of that, so it doesn't concern me in the slightest. That's not a problem. Obviously the water has to seal around the outside, but there's no real pressure there for that, so that'll all cope, no problem at all. We could have yacked another 20 thou off the head, but I'm not on for just removing material for the sake of it, you know. This is going to be a 930cc engine from an 875, so the chamber I've left standard. So we're going to end up, because of the capacity increase in the cylinder, we're going to end up with about 11:1. Anyway, we will measure it. Well, I've done loads of these, so I know roughly what it's going to be. It just gives them a nice little bit of torque, you know. So we've got the engine here. Just this is it says an 875 imp block, and this is the gasket. This is the new improved gasket, I believe I got from the Imp Club spares last night, which doesn't have the red bead around the outside that used to allow them to deteriorate. So it's on 930 pistons. It's on a fresh bore. The pistons have just got some, this is just storage marks, they're not actually old or anything. So that's going to have this head on it, and we're going to run it together with the SU carbs. Okay chaps, we're back with the 930. He's all dressed up now, ready to go in the dyno, so we're going to run him together in a minute. Lovely pair of period SUs, I really like them, I think they look great. Well, obviously it's all tamed for mid-range torque, this engine. It'll be about, you know, all about torque rather than the horsepower. It's not going to be a big horsepower engine. It hasn't got the area in the cam, which is why I'm doing this video really. It's got a reprofiled, if I zoom in there, you'll recognise them last three digits, 157 on the end of the cam. That denotes it was a sport cam. But if you look, you'll also see the base circle's been ground, so it's not on 23.8, it's on 22mm now. So basically, it's been off to Kent cams, and they've reprofiled it, and they've shrunk the base circle so they can reshape the nose of the cam to do something different. So I thought we'll do a bit of a cam timing check on it. It's only got 300 thou lift, so it's not going to be racy. It's just going to be a bit better than an Imp Sport, I think, and which will be perfect because obviously now it's got the extra capacity, because we bought it from 68mm to 70mm, so it's now a 930cc. And earlier on in the video I said that by leaving the chamber standard and running with the head gasket with the piston just slightly protruding, you know, we tend to see about 11:1. I don't want to get a big head, but guess what? It had 23.1 cc's in number one chamber, so the compression ratio is 11.1:1, which is perfect for the road on pump fuel and running thermostats and things like that up at 70-80 degrees water temperature. So what I've done, I've not touched the which is jammed. What's going on there? Oh, there you go. It's a bit sticky, that. The bob weights in the Dizzy, I've left them as standard at the moment. This is the later 45 D4, but I've tried to make it into a 43 D4, which is the one which doesn't have the VAC Advance on. The VAC Advance really, you know, it only works on idle, and I just think it confuses the job. So we're just using the bob weights and the bottom of the distributor to do the advancing. So what I'll do is, when I've worked out where peak torque is on the engine, I'll decide then from looking at the advance curve where it starts to advance and where it finishes advancing, as to whether I'm going to put stronger springs in it or lighten the weights or whatever I do in there to make the advance curve suit what I want it to do with the cam. But the reason I'm talking about this now is because I went to the Imp Club meeting last night and got grilled by several members who obviously haven't grasped how to do the cam timing just yet. So if you already understand it, just forward wind for 5 minutes, but we're just going to go through it dead simple and dead quick. And I've written the figures down here. This is for my mate Stuart. Stuart was the chap that put down in the the favourite engine sound game we did with the winner t-shirt, he put down in the comments section Sierra 2.3 diesel. What a legend. Anyway, as we can see, this one has an inlet lift of 55 thou and an exhaust lift of 38 thou. So what am I on about? What I'm saying is, at TDC, so bring the engine round, so the number 1 piston's coming to the top, it's on the marker there. The inlet valve, zoom in, you can see the bucket, the lobe is round here, and it's just coming on lift now, and the exhaust is just coming off lift. So at this point now, with the tight side of the chain here, so there's no slack in it because we're coming in a clockwise direction, in the direction of rotation of the engine. That now will have 55 thou of lift on it, and this one will have 38 thou of lift. And that is the amount of time, the amount of lift that the valves are left open when the piston is doing the exhaust stroke. So the piston's come up and he's shoving the exhaust gases, or the exhaust gases are probably so volatile they're in a rush to get on the exhaust pipe. So what they do is the exhaust valve is just starting to shut because the piston's come to the top, and the inlet valve has started to open, ready for the air to be pushed in at atmospheric pressure into the cylinder. So we're not going to get too far involved, but it's not suck, squeeze, bang, blow. It doesn't suck. The air's waiting to go in. The 14.75, whatever it is, 1 bar of atmosphere is waiting to go in the engine. The piston merely causes a depression. If we can cause a further depression by the speed of the exhaust gases going down the pipe, causes a backdraft, because we just said we've got both valves open. So what's going to happen next is the exhaust valve is still open as it's starting to shut, and the inlet valve's open. So the idea is that the exhaust, the speed of the gases leaving, scavenges even more fuel and air, or fresh fuel and air, into the cylinder, because it's all about getting a nice fresh fill ready for the next bang. We want to get as much of that exhaust gases out. So hopefully, if the exhaust is all good, a nice 4 into 2 into 1, it has actually got a small bore Jan speed on it, which is very pretty. So the exhaust gas is leaving in the rush, backdraft, inlet valves are starting to open. It'll draw a bit of fresh air. Obviously we will lose a little bit of fresh air and fuel out of the exhaust port, because they're both open at the same time, but the compromise is we get a better fill. So it all happens very quickly. This, I'm sure someone who's educated in the area could explain it better, but that's the basics. So let's see how I've got on. So I'm going to pop this on here now, and one-handed, and try and explain it. So all I'm doing is I'm putting the pointer onto the top of the cam follower. Okay, I've nipped it up, so we can see in there just about, if I had a torch. Where's the torch gone? There you go. You can see there's the cam follower, there is the pointer, and he's just on there. So if I zero this, I know that, I'll just zoom out, I know that this is come round to top dead centre. The piston is at the top. So what we're going to do is we're going to back him off, because he's on lift. We want to know what the TDC figure is, so we have to come off lift so that the bucket comes up to its clearance point, so we can see. So I'm going to go anti-clockwise. I'm just going to zoom in a little bit. Right. Oh, God, it's moved. Okay, we're back on 0 again. Right, so let's back off. So that's 25 thou, 30, 35, 40, 45, 50, 55. Oh, that didn't work out, did it? We'll call that 57 thou. So it's got 57 thou of inlet lift. So we want to measure the exhaust now. So obviously we're backed off, we're nowhere near now. The piston's on its way back down. So I'm going to bring the crankshaft back round in a clockwise rotation until we get back to that 0 point, and then we can swap the DCI gauge over and we can measure the exhaust lift. So I'll try and do this one-handed again. Just bring that off there. Quite tricky one-handed. I'm not very good with both hands, so This is a real challenge. Right. Okay, Stuart, you're following me. So we'll zero this. Okay. And we'll zoom out so you can see what I'm doing with this. So because the exhaust cam is on this side, the inlet cam's there, and the exhaust cam is now going to come off lift. We want to know what the figure is at TDC. So we're going to move the crankshaft pulley in a clockwise direction now. And we'll see, we'll just zoom in a bit more. Right, there you go. So I'm going clockwise. That's our 25, 30, 35, 35 foul. So I was a few foul out in my measurement, so it was right. So we had more on the inlet, and it must have been TDC that was slightly out. But basically, we got 38 on there, and it was 35, and we had 58, and it's 55. So a bit of to and froing, but hopefully now you get the gist of how we measure the TDC figure, Stuart. Right, I'll get the cam cover on, and we'll get a tune out of this, and we'll see where it does its power. I suspect it'll all be over by 5,000 RPM. It'll hang on till 6, but I think peak torque will be about 4,000, but we shall see. Right, okay gents, we're on the dyno now with the 930, with the twin SU carburetors and the little Kent cam based on the reprofiled in sport cam. Got to say, what a lovely friendly little engine it's been. Just run it in, nothing too dramatic. I have made it work virtually from start up like a human. It needs to be made to work, these engines. No good leaving them to idle around, it doesn't do them any good. So he's bedded in now, settled in really nicely, to be fair. I'm really happy with it. I'm actually quite liking these SUs. Normally I just do Webers and Delautos, but oh god, I forgot the microphone. Anyway, we'll go without the microphone for now. Anyway, so yeah, it's been good as gold. And the SUs, I think, because of this nice long banana type manifold, which I'll show you in a minute, it's quite a long distance between the butterfly and the back of the valve, which is giving it good torque for the capacity of the engine it is. It's showing about roughly 60-65 foot-pound. I did get the peak torque wrong. It's doing it at sort of 4,500. It starts to tail off at 5. Now, I'm not actually like dyno testing this and tuning it. All I'm doing is I'm sort of proving the engine. I said to the chap, you know, I'm not an expert on SUs. There's some old boys out there that have messed with minis all life, and they will know how to tweak these SUs on the rolling road to get the very best out of them. I think it's going lean top end, which is a normal characteristic of an SU carburetor on an imp, because they're designed for a low revving engine rather than a high revving engine like the imp. So yeah, you'd have to mess around with the needles on the taper and try and get some more fuel at full flow. You know, when the dash pot is at full height. So I'm going to stop waffling now. We're going to run it. I'll put some load on. We're just going to see, just because the airspeed, nice 533 head, just picks up instant. That's got loads of load, you know, good load on it there. So 3,500 revs, about 60 foot-pound. Just bring it a bit lower. I've only got 30 degrees advance, or 33 in it at the moment. It will run more when it's running, but the most, just over 12 there, just over about 65. That's 3. It will run more advanced when it's fully bedded in and it's in the car, and he's took it to a rolling road, and he'll get a bit more. But for his first 1,000 miles, we're just going to leave it as it is, because he's desperate to get it back in the car and use it. We'll wind the dyno back now. It's holding 63 there at 4. Missed there, what's that? At 5,000 it's holding 12.5. Right, let me just go and investigate, see what's going on, make sure no wires are falling off. Right, I've just adjusted the fueling a little bit, which you've got like a screw underneath the SU carburetor, like a hexagon, and if you screw it in upwards clockwise, then it obviously raises the height of the jet
advance was fine. I checked it. It's doing all of its advancing between sort of 1500 RPM and 3,500 RPM. Then it seems to fall off, and then there's only a few degrees to be had. So for what we've got with this cam, I'm quite happy with that. It's early, but it'll suit it. Right, let's try and get a 5,000 figure. I don't really want to rev it too much. It looks quite fresh. So it's 4, 5. A bit further. Right, a bit more. There we go. We've got a 5 now. 5, 5. That's doing it. Just the dyno is so slow to respond. 5, 5, still holding 65. It's alright that. Just do a little calculation. 55 multiplied by 5,500 equals that, divided by 5252 equals 57 horsepower. But it's got good torque, so it'll drive nice. That instant. I'm assuming that the smoke and the dyno cell and off the silencer is because the engine was in quite bad shape when it arrived, so the silencer will just be full of smoke. It's on new bores and new pistons, so it won't be coming out of the engine, and it's got valve guard oil seals. But we will do a double check before we send it out. Maybe we'll go in together and pull the exhaust pipe off. But we'll just go and see it together now, and we'll do the old oil leak test, see if he's survived with no oil leaks, because it has got a rear oil seal conversion. Looks good, that. Nice super manifold. Okay chaps, that's it for this week. Hope you've enjoyed the episode. I will look forward to seeing you next week on Sunday, which will be Christmas Eve, and I'll hopefully have plenty more to waffle about by then. Alright, have a great week. I'll see you Sunday.